let's talk about one other thing here. That is scatter plots. And good news is I have this on handout here. Save you a little bit of writing. All right, so in scatter plots, what I've got is I've got some data. And in this case, my data is year and then the life expectancy in years. So I've got 1920, 1930, 40, 50, and 60. And then the life expectancy, 54.1, 59.7, 62.9, 68.2, and then 69.7. Okay, so that's what you got there. Okay, yeah. So we'll do some more with this sort of thing later, but for right now, we're just talking about a scatter plot. Well, a scatter plot is just graphing the data, so it's really just what we were doing earlier with the table here. This is just a table here, and we're going to choose one to be X, one to be Y. Of course, we probably choose the X here as the year, and then the Y is life expectancy. This is the way we probably most often see it. The other thing to note here is I'm only dealing with part of the Cartesian coordinate system here, the plane, the XY plane, because I'm starting X is at 1920, and then the Y is only positive, well, it's larger positive numbers. So what I'm trying to say is, yeah, that really I'm only dealing with kind of the upper right quadrant of, instead of the whole thing. We don't have to draw the whole thing here, is what I'm getting at. Okay, so we're going to let X be the years, and so yeah, we'll let the year be over here. One thing I'd like you to do is label these so we'll know what this graph means. That's all a scatter plot is just a graph of the data. So we'll label those. Now the other thing is, I could put 1920, 1930, but let's go ahead and make a little bit of a shorthand notation, I guess you might call it. Let's go with the year 20, or yeah, X is 20, that's going to be 1920. So I don't have to write, I mean, could go ahead and write 1920, but probably make it look better if I do my years like that. So I've got 20, 30, 40, 50, 60. So whatever we do, just make a notation that that's what it means. Now over here, they're really, I mean, they're large numbers, but they're kind of packed together, and so I probably don't want to mark off a scale of 1 here, starting at 1, right? Because I would have to go 54 to 70 almost there. So let's make a little adjustment here. Let's start over here at 50. That'll be okay for our purposes. Start at 50, and then see, we're going up to 70. So mark off 2s, 5s. 5s will be fine, I think. Let's go 5, 55, 60, 65. Oops, what did I? So as you can tell, there's a little leeway here on how you do it. If you're doing your own, of course, you'll have to. Yours might be I might skip what I've got on the handout there. Yeah, I might every 2 make a 5, I guess. Just so it'll get spread out enough. Those are judgment calls. You do what you want on those. All right. And then it's just plotting the data. We've got 20 is 54.1, and 30 is 59.7. Yours probably looks better. You got the grid there. 40 is 62.9, so let's say it's about, that's right about there on mine. And 50 is 68.2. Right there. And that's almost 70 for 60. So. Yeah. So that's your scatter plot. Just plotting those points at all. Okay. Now, what we could then talk about, well, it looks like that's looking a lot like a line, isn't it? So that's where we'll go with this is then, well, that looks like a linear model, so I'll find a line for that. Maybe it looks like an x squared graph, so I'll do an x squared model. But anyway, that's all you have to do right now is plot it out. Question?